we're going to look at what if you're actually looking at two graphs at once. Well, if they actually ask you to do two graphs at once, it means that you're looking for where the two graphs intersect. So what you actually do is you do a mock-up of both graphs. You say, okay, well, I'm going to do the shading on my first line. And then you do your second graph on the same picture, and you draw that in, and you do its shading. You do its shading. Okay, but that's not your final answer. Your final answer is still going to be your two graphs, whatever they may be, but your shading on your final graph should only be where you are overlapping. That's the only part that should be in your final answer is the overlap, the intersection. So in my final answer, I should only be coloring in the overlap. So let's take an example and let's see if we can take a look. So on this first one, I'm actually going to do two graphs. The original off to the side, and then the final answer graph where we're only doing the overlap. So one at a time. So the first one we're going to look at is the 3x minus y is greater than or equal to 3. So the first thing you'd want to do is realize that that's a line and graph that, maybe put that in slope-intercept form. So to do that, you'd subtract the 3x from both sides. And let's see, that would get you, be careful, a negative y is greater than or equal to negative 3x. That's a positive 3, so plus 3. Now to continue along, you'd have to divide both sides by a negative 1. The problem is, remember that that flips the direction of the inequality. That means that instead of it being a greater than or equal to, it's going to flip to being a less than or equal to. Also, keep in mind you divided everything by a negative 1. That will turn this negative 3x into a positive 3x. It will also turn this positive 3 back into a negative 3. Now, the question is, how do you graph that? Well, first of all, it's let's see, the equal to means it's a solid line. We'd start out with the negative 3 because that's your y-intercept. So I'm going to draw this on both graphs at the same time. So I'd start at negative 3, the y-intercept. And then I'd use my slope here, which was, it looks like a positive 3. Remember, a slope of positive 3 means you actually had 3 over 1, which if you use as a rise over 1 would be up 3 as your rise, and then to the right 1 as your run. So you'd go up 3 and over 1, up 3 and over 1. Remember, the equal to meant that we had a solid line. So we can go ahead and draw that on both graphs as our solid line. Does not have to be perfect. But I don't want to actually shade the graph on the right until I have my final overlap. I'm only going to shade the one on the left right now because I'm doing kind of a mock-up. Well, let's see. Remember, to figure out which side I'm going to shade, you need to test a point. So I'm going to test the point, just like always, 0, 0. So let's plug in 0 for x and 0 for y. So if I plug in, notice, 0 for x, what happens is we get 0 is less than or equal to, well, we get 3 times 0, which is 0, minus 3, which is going to actually be 0 minus 3 is negative 3. So the question is this a true statement? Is 0 less than or equal to negative 3? And that is, the answer is no. So the answer to that is no. So that means the point 0, 0 does not work. So for this particular graph, we would shade the other side of the line that 0, 0 is not on. And I'm going to try and use blue for this graph just so that it sticks out. Remember, I'm not going to shade my final graph yet, because I only have part of my answer and I don't know what the overlap is. Okay, so that's our entire first graph done. I need to see how it compares with the second graph. Well, they usually do this. They made the second graph at least a little bit nicer. Remember, if you just have an X or just have a Y, it's one of your special lines, either a horizontal or a vertical. In this case, the Y tells us, hoy, that Y graphs are horizontal. So it's going to go through Y at 3, so you'll go up 3, and you'll have a horizontal line at 3. Be careful before you just draw it, like I was about to, is you have a less than, not a less than or equal to, which means that that line should be dotted. So at 3, I should be drawing a horizontal dotted line on both of my graphs. I'm going to, again, hold off on the shading on the final graph, but I can at least draw the line. Okay, which side of my horizontal line do I need to shade? Well, if you weren't sure, do what we did before. Take 0, 0 and test it. Plug in 0 for X and Y. Well, in this one, it just would mean that you're plugging in 0. There's only a Y there. So you'd get 0 is less than 3, which actually does work. 0 is less than 3. That means that 0, 0 would work for the horizontal line. So that means you would shade that side of the horizontal line that 0, 0 is on. So that means you would shade the underside of that horizontal line because it worked for the horizontal line. The 0, 0 worked. All right. So that's our mock-up with both graphs at once. The problem is, what's the part that's my final answer, which is where you are overlapping this piece. So only that piece should get shaded in my final answer. So let's do that. Let's take that piece here and shade it as my final answer. So I'm going to go over here and just only shade that part of my graph. Okay, so my final answer should only be the graph where I have both lines drawn and I only have the overlap from the mock-up graphed. I shouldn't see both colors. I should only see my final graph, the overlap. But I'm done.